This video is brought to you by TS4U IT Engineering Bootcamp.
A little bit your the experience with how you will do this. So I want to actually design a system as an example similar to the Twitter dummy, and I want to scale. I want this scalable. It should be highly available, and of course, I want to save some money. I want it cost optimized. So consider a situation that when I post something, it might get few likes, comments, reposts. But when a very popular person like what? Like the Jeff Bezos, Elon Musk, they have billions of his followers. We log in and do likes, comments, like the system is flooding now. And the application will get very high spike in the traffic and usage. How would you architect this? Again, if you do not have the experience, you are fine. If you have the experience, you can actually share the best practices, how you will start.
Yeah, so we technically didn't have this kind of issues where we needed to deal with this kind of scale, but what I can think of is we can actually have a distributed system for this, and we need to deploy the distributed system in a distributed architecture as well, right? So that we can scale indefinitely. And since this might be a social network, or this is a social network, right? So we've got to have like users from every single part of the world. So our data center strategy, like data center selection strategy, needs to have that same kind of like capability that, okay, we can actually decentralize our application by using different regions and availability zones, right? So first of all, we need to ensure that. And second, I need to specify some sort of like caching mechanism or some sort of CDN to handle the front end, so that no matter where our user actually is, they can go through that CDN and then they will be served from like a specific server near to them. Okay, so that we don't just flood one single server in one single region with users coming from all around the world, right? So if we use the CDN, just like I can think of like AWS CloudFront as the CDN, so that will be our customer facing side of the application, mostly the front end. So we can actually use that to receive requests from all over the world, so that our servers don't get just flooded with the users. And then as the backend, what we can do is, if the backend is distributed, we basically can actually have a cluster of servers which are actually spread all over the world, so that wherever the user is, we can route that user to the closest server to them. Okay, so they can actually receive requests from a specific geographic location. Okay, we can actually achieve this from the domain, like if we use the route 53 geographic location like routing, so it will basically route the users based on the user's location, like where he's coming from, where he is actually like doing the request from, and then they will basically go to the server nearest to them. So backend server won't be flooding at that scale. And then for the database, this will be really tricky, okay, because the database can be distributed, but it will impose some more problems, because if we have database spread out to all over the world, then since this is Twitter, so they have a lot of read writes at the same time. Okay, so what we can do is we can use some sort of managed databases with high input output ratio, like high IO, so that it can handle millions and millions of requests per second, and we can have it as a like read write replica mode, so that we can have multiple read replicas, we can have multiple write replicas, so that like if this is a write request, it goes to the right server. If it's a read request only, that okay, I like to read only some tweets, then we can actually have those like requests go to the read replica, so that our database requests are also distributed as well. And then the final catch that you said, that okay, if Jeff Bezos actually does a tweet, then how does it actually goes to all over the world? So I can think of is I can cache that specific specific tweet, and then I can just update the cache all over the world to show that, okay, this is what the new tweet is. You don't need to go to the database, you just have it because this is from Jeff Bezos, and this is gonna be around for a while, and yeah, everybody should have it. So we just read that tweet from the cache. You don't need to like go to the database and see, okay, this is what the current situation is. And yeah, I think this should do. And
Are you going to
definitely,
use
yeah.
are you going to use the Redis in this case? You mentioned the cache couple times, no?
Yes. Definitely we can use Redis, or we can use any kind of like managed caches as well. Like we have Elastic Cache on the AWS as well. So we can definitely use that as well.
Sure. So I just want to see the demonstration. So a user is the complaining, or a group of users is complaining from the South America that they are unable to see his tweet because it is loading and loading and loading. On the other hand, people from North America on the West Coast,
Yeah.
they have no complaint. And our team
Yes.
is monitoring the entire process. So what steps would you follow to identify the South American, the complaint that user is unable to see the loading of Jeff Bezos, the tweet? What you will do as a user?
Yeah, so as I said, we can use the geographic-based routing to detect where the user is coming from. Okay, and then basically what we can do is go to that region and see what's the current status of the servers, if the caches are working correctly, if the databases are actually giving solid responses from that specific region, because the issue is region specific, not global. Okay, so we can monitor the response time of our APIs to see if we have any bottlenecks on the system. Okay, and then we actually can go through the memory and CPU usages for our cache servers. And the another thing we can say that we can actually invalidate the cache. Okay, so this is the fastest way to this kind of like resolve this kind of issues. So if users don't see the latest updated things, we can just invalidate our cache to reload the cache. Okay, so it will basically update all the things in the cache. If there are any temporary things that were like stuck there, it will like go away straight, and then yeah, it will just re-update the cache with whatever happening in the world right now. So yeah, I think this should solve the issue. And definitely from the networking perspective, I definitely need to actually see if all of the servers are actually up. First of all, definitely we already checked that. And then if our server's response time is going good. Okay, so if the cache is the issue, then if we like reload the cache, invalidate the cache, and then we can check the response time again. If we don't get any like updated response time, then it might be the database. So we definitely need to go inside the database and see why the response is getting slower. Okay, so then we might need to work with our database engineers to find out the bottlenecks, because that's not really our side of concern. So yeah, we can work it out together as a team maybe. And definitely we need to check the DNS servers like activity on those specific location, because sometimes the DNS servers are out of the service and then users can't really reach to our application. So it's not my like always might be our problem. Okay, it might be our like third-party problem. Let's say we use the Google DNS. So Google DNS also might be having some issues. Sometimes it's the cache provider or the CDN provider that is down. So it might be their problem as well. So we definitely need to check all these points and then provide a solution.
Got it.